So negative negative makes a positive 4.5 pi. And finally, we just add them together. So approximately 2.83 pi. And there is our surface area. So not too bad when it comes to it. Hopefully you guys can see it. But again, a little bit more work to do with it. And it's the reason why a lot of the stuff you'll be seeing next semester in far more detail once you get into double integration. And when it, things like that gets a little bit easier to deal with all this horribleness. It takes too long to deal with. Okay. All right, let's try one more down here. Find the surface area obtained by rotating the curve. So we have a kind of like a circle here. Now it's y, so be careful. From y, from 0 to 1, about the y-axis. So we're doing about the y-axis. Therefore, we have to everything respect to y. So in other words, we have to solve for x here. So we'll bring this over. So we're going to have x to the 2/3 equals 1 minus y to the 2/3. Yeah, 2/3. Okay. And now we're going to raise everything to the 3/2 power now, right? So then x is equal to 1 minus y to the 2/3 raised to the 3/2 power. Right, just flip them. And now we take the derivative, so dx dy. So derivative of the outside times the derivative of the inside. Gives me that. And now we plug it into our equation. So surface area is equal to the integral from 0 to 1, 2 pi out here, of our original function. So this is our original function here, of 1 minus y to the 2/3 to the 3/2 times our arc length. So all of this squared. So let's see if I can simplify this a little bit. So notice that's kind of nice, these to cancel. We just get negative of it. So it's going to be that on top, and we'll leave this on the bottom. The negative there. Okay, I'll give you guys a quick second to catch up what we just did. Okay. All right, and now we just square it. So those cancel, and this becomes y to the 2/3 power. Okay. Now, you may think, oh boy, oh boy, oh boy. But actually, it's actually not that bad. Because if we put this stuff together, just right here, so I'm just going to leave this here, I'm just going to rewrite this portion. If I multiply this by y to the 2/3, be y to the 2/3 power, and then add this together, notice something really nice does actually cancel out. These do. So in reality, this is 2 pi integral from 0 to 1 of our original function times the square root of 1 over 2/3. Okay, let's figure out how we're going to do this stuff here, right? So let's just quickly do a little side note of what this means. So again, let me just go and see what's going on here. All right, so This is the same thing as saying this. Right? Now if I distribute this, notice the 2's cancel. And we're just left with y to the 1/3. So that happens here. You guys see that? Okay. So now this integral ends up being this. Exactly that. Okay. Now you may be saying, okay, that still doesn't help me. It actually does. Because now we're going to let u equals exactly on this side, so 1 minus all of this horribleness. And then we take the derivative. This is going to be 2/3, negative 2/3 y to the negative 1/3 power. Now notice that's exactly what I have here. Right? I have exactly that going on there. So that's perfect. The only thing I don't have is this. So if I rewrite this, this is now going to be the integral of negative 3/2 of just u to the 3/2 power. Okay. All right, so going by this process, this is going to be u to the add 1. So that's going to be 5/2. This is 2/5. And this is times negative 3/2, evaluated at 2 pi with 0 to 1. Right, all that horribleness. So before I just plug in u, I want to simplify exactly what we have so far, right? Just to see what in the world is going on. Okay, so all these numbers everywhere. So let's see. So cancel, cancel. And looks like that it's everything that cancels, right? So we have negative 6 pi over 5. Right? And then u, which was to begin with there, all raised to the 5/2, evaluated from 0 to 1. Thank goodness it's from 0 to 1, right? Because, you know, if I plug in 1, it's much easier. Plug in 1, 0, it's also much easier, right, when it comes to it. So even better. Because notice, if I plug in 1 now, it's all 0. 1 to any power is just 1. 1 minus 1 is gone, 0. So technically it's 0 minus what happens when I plug in 0. So plug in 0, I get 1 out. 1 to the 5/2 is just 1. This is negative 6 pi over 5. Negative, negative makes a positive. Look at that. And that's what I mean by the integral is actually not that bad. Even the evaluation isn't that bad. It's just the setup is the main stuff we have to deal with when it comes to this section. And there we go.